the 2026 Emerging Tech Trends opening panel. Hello, everyone, and welcome to the 2026 Emerging Tech Trends Opening Panel. And if you're curious about the biggest tech trends for the year ahead, you've come to the right place. I'm Tiffany Nielsen, and joining me is the CEO of IoT Marketing, who is the producer of this event, Johannes Beekman. How are you today, Johannes, and where are you joining from?
I'm doing great, Tiffany, and welcome to all the other panelists. And I'm joining from Austin, Texas.
Great. Thanks, Johannes. And we also have Tom Galaney, the founder and CEO of Hippocampus Partners. How are you today, Tom? And where are you joining from?
Doing well. I am joining you from the middle of Silicon Valley, in the San Francisco Bay Area.
Thanks, Tom. And last but not least, we have Dr. Scott Gerard, the Chief AI Officer at Knowledge Reactor. How are you today, Scott, and where are you joining from?
I'm doing really good, Tiffany. I'm from the Raleigh, North Carolina area, so I'm out on the East Coast.
Scott. And let us know in the comments where you're joining from. We'd love to hear from you, and any other comments that you want to share, we're happy to hear from our audience. And we'll be covering a lot of ground in this session, but to start things off, I think it's fair to say that the biggest trend for 2026 continues to be AI. But AI is such a multifaceted technology, so let's break it down a little bit. Starting with physical AI, which we saw a lot of at CES 2026 in Las Vegas. And you can check out the highlight reel from our latest episode of TechScope News, available on TechScope Connect, as well as our YouTube and our company page on LinkedIn. Johannes, can you lead us out by sharing exactly what physical AI means?
Sure, Tiffany. So when we talk about physical AI, we're not talking about software that only lives on a screen or in the cloud anymore. We're talking about physical AI as an artificial intelligence embedded into real machines, systems that sense what's happening, decide what to do, and then act in the physical world, often in real time. That last part matters because the physical world does not pause. If a robot arm is placing a component, or a vehicle is navigating a busy street, or a machine is handling a fragile material, you cannot afford long delays or vague outputs. Physical AI has to operate with tight timing, clear boundaries, and critically, control that holds up under real operating conditions. And this is not a brand new idea. NVIDIA CEO Jensen Huang has been calling this next wave of AI for some time now. AI that understands the world not just as text, but as physics, motion, friction, and cause and effect. The message has been consistent. Once machine can perceive and reason in context, autonomy becomes inevitable. The harder question is how that autonomy stays within acceptable limits. At CES 2026, we saw this become tangible across manufacturing, robotics, mobility, and industrial systems. And the major theme was moving beyond rigid programming. Instead of telling machines exactly what to do step by step, we are seeing them trained through simulation and virtual environments, then refined in the real world where variability, drift, and rotation behavior become unavoidable. In manufacturing, physical AI shows us equipment that adapts continuously, adjusting force environment based on sensor feedback rather than waiting for a quality alarm or an operator to intervene. That starts to stretch traditional SPC assumptions because the process itself is learning while it runs. In robotics, it includes collaborative and service robots that operate safely around people by interpreting context, where hands are, what objects are present, what normal motion looks like, rather than following a fixed script. Control shifts from static limits to dynamic behavior envelopes. In mobility and industrial equipment, it looks like onboard intelligence that fuses camera, radar, or other sensors to make local decisions, whether that's a vehicle managing hazards or heavy machinery operating on a job site, often without time to ask for human confirmation. So the key shift is this: physical AI closes the loop between sensing and action. It moves AI from recommendation to responsibility. And when systems adapt in real time, the question is no longer whether they are in control, but how control is defined, measured, and maintained as behavior evolves. And that's why the real conversation for 2026 is not only what can these systems do, but how do we apply safety, SPC thinking, and governments to systems that are explicitly designed to change their own behavior. It's also why we are taking this discussion offline in a small practitioner-focused SPC of Adaptive AI Systems Roadshow, because these issues tend to surface fastest when engineers, quality leaders, and operators are forced to reconcile theory with reality. And just one last thought: if your system framework assumes stability, but the system is engineered to adapt, then control has quietly shifted from something you verify to something you assume. And that assumption is rarely visible until it breaks. We continue to unpack where those assumptions show up and how teams are addressing them in our Adaptive Physical AI Intelligence Brief weekly and our roadshows.
Thanks, Johannes. And now that we have a better understanding of physical AI, one of the most tangible examples of this shift is humanoid robots. So, Tom, what advancements are you seeing in this area, and what risks should we be aware of?
Well, thanks, Tiffany. It's been a really exciting time in robotics because historically, we've generally only seen two business cases for robotics. It's either something in remote control, perhaps in a hazardous environment, or it's a repetitive task, something in a factory that's done 100,000 times. And with the AI addition to robotics, we are now seeing completely new business models where we can give high level instructions or a goal, and the robot can take action and make decisions from there. So that's very different than what we've been able to do before. And it opens up an entire new uh, landscape of applications. It's going to transform robotics, and it's going to make the field significantly larger than it's ever been. The challenges of that are, of course, that we have AI that is making decisions, but it's not following a set script. So this leads to some differences in how we have to manage risk, especially things that are moving around a physical human environment. We don't want to see any humans injured. We also need to keep an eye on physical areas, privacy, and then of course these new systems are much more complex. And with that complexity, we have to develop means to supervise our non-human coworkers.
How do you supervise non-human coworkers? It's a new world. And as physical AI and humanoid systems advance, it's clear that no single model can handle everything. Perception, reasoning, and decision making all have to work together. And that's where composite AI comes in. Scott, can you shed some light on this trend?
Yes, composite AI is not currently a very well-known term, but Gartner has been tracking that since at least 2020, and it's this last year it's breaking into the top of their hype curve. So I expect you're gonna hear a lot more about it in the coming years. Now, my definition for composite AI is that it's multi-agent, it's multi-tool, and it's multi-AI. Many agentic systems are already multi-agent and multi-tool, so that isn't really the big new thing. The most significant addition is the term multi-AI. Some tasks can really only be addressed by an LLM, and so we need to use them there. Absolutely. But Andrew Ng, who's a famous computer scientist in the AI field, recently stated that LLMs are amazing yet highly limited, and I definitely agree with that. So while some tasks are great for LLMs, other tasks require deterministic correctness without any hallucinations. And Not surprisingly, there are decades of valuable AI results around optimization, and those tools often will scale much farther and much faster than an LLM would be, and they're also a lot cheaper. So this is one of some of the different AI, some of the different multi AI agents are out there, and I would encourage you to not forget about them. I mean, physical AI systems must be highly correct, as Johannes mentioned, and composite AI, I believe, provides a great foundation for physical AI. So use LLMs where they make sense, but they aren't the best solution for every task. And composite AI just simply acknowledges that. But composite AI isn't all sunshine and rainbows either. Composite AI is not some magic potion that's instantly going to solve all of your problems. They are distributed systems, and distributed systems are much more challenging than single sequential systems. Now, we can reduce the complexity quite a bit by implementing multi agent, multi tool, multi AI workflows where only a few agents are executing at a time. That's not everything that Tom was talking about, but that's one way to reduce some of the complexity. And it reduces it by reducing the asynchronous operations. So I expect to see composite AI gain traction first as workflows. But it does require that your composite AI architect understand both generative AI as well as traditional AIs. And that requires some substantial technical depth. So that's the things to consider. System observability also becomes a really hard requirement. Debugging these kinds of systems doesn't look like debugging as much as it is distributed systems archaeology. It's really can be very challenging. Composite AI is overkill for some systems, so don't over-engineer your system. Only use it where it really makes sense. I want to go on a little bit more, Tiffany.
Okay.
I want to draw an analogy here. So, around 540 million years ago, there was an explosion in the number of different biological life forms on planet Earth. And this was called the Cambrian explosion. There were 10 times as many distinct life forms after the Cambrian explosion as there were before it. So, analogously, and only analogously, I don't want to push this too hard. I expect that we're going to see an AI application explosion where we create many new AI application types, types that we've never seen before, and types that don't currently exist. There'll be numerous instances of each of the application type, but we'll just talk about them as the types. Let's just think about the types for a minute. No one currently knows what all those new application types will be, but here are some of existing application types to kind of help you understand the kinds of things I'm even talking about. Social media is a recent type of AI-enabled application. They've been around for a couple of decades, but that's a new type of system that we didn't see before, in the last century. Chatbots are another type of application, but it's only roughly 3 years old. Tom already talked about humanoid robots. We've seen and we've imagined those for decades. Some of the working examples are starting to show up, so that's good. But I also think there's going to be a lot of non-humanoid robot application types exploiting both AI, IoT, and physical AI, as Johannes is talking about. And who knows where some of these application types are going to go in the next decade. One of the key enablers for this application explosion is AI in general, of course. That's one of the new ingredients on the menu that we can employ that we didn't have before. And there will be some brand new and more powerful AI algorithms, but that isn't really what I'm trying to get at here. We can use those if they're available, but I think one of the other key enablers here is composite AI's ability to architecturally combine multiple already existing AI components together to create totally new application types. And application combination is just another reason why I'm so bullish on composite AI.
Thanks, Scott. I'm sort of mind blown over the Cambrian explosion and all these new types of AI, but we'll see what happens. It could be I won't even get into that rabbit hole in this speculation. One place that we're seeing composite AI really come to life is through AI agents. And these systems can reason, act, and operate with a higher degree of autonomy across workflows and customer interactions. Johannes, we're seeing agents deployed across many industries and applications, especially in retail and consumer facing use cases. What do you predict for AI agents in the year ahead?
Well, Tiffany, AI agents are going to be dramatically easier to build over the next year. If you haven't built one last year, you're definitely going to build a bunch of them this year. In 2026, creating an agent will feel less like an engineering task and will feel more like configuring an agent. Tool chains are maturing, integrations are getting simpler, and templates are everywhere. As a result, almost every organization and plenty of individuals will be deploying agents into real workflows. That accessibility is both the opportunity and the risk. When agents are easy to create, they are also easy to deploy without sufficient testing, governance, or long-term ownership. We are already seeing early signs of this in consumer and retail use cases. Agents that work well in controlled scenarios, but degrade over time, behave inconsistently, or quietly introduce security and compliance exposure. Maintenance will be a major blind spot, definitely in 2026. Agents are not set and forget systems. They rely on changing data sources, APIs, and models without clear responsibility, version control, monitoring. Performance drift is almost guaranteed. Cybersecurity is, of course, another concern. Every agent is effectively a new surface into systems and data. Poorly scoped permissions, weak authentication, or opaque decision logic create attack surfaces that many teams are not prepared to manage. So the question for 2026 is not whether AI agents will proliferate, they will. The question is whether organizations treat them as serious operational systems or as experiments that accidentally end up in production.
Thanks, Johannes. You brought up some great points. And though AI agents are becoming more autonomous, they don't operate in a vacuum. To be effective in the real world, they often have to make decisions close to where the data is generated, on devices, sensors, and machines. That brings us to Edge AI and IoT. Tom, how are advancements in Edge AI impacting IoT?
Thanks, Tiffany. We've got some interesting things going on in Edge AI. One of the things is that we're finally seeing small systems that are able to interact. Sorry, we're seeing small systems that have enough horsepower from a hardware point to run models and small action models as well as small language models. What this is allowing us to do is to make the decision directly on the edge, on site. So we can the most common example you see of this are things like self-driving cars. These are devices that are able to make decisions rapidly on site and take action and make decisions. One of the big issues that we have is with types of devices out there is that if they're not using Edge AI today, they wind up having to go back to the cloud using a communication system to interact and make decisions. That's not practical in most cases, especially if you're in an area where the communications may slow down, as well as just managing things in the cloud. It's much easier to make a local decision that's right in front of the device. So we're moving away from simple sensors that are just sending data to the cloud and waiting for a response back. And we're able to take local action directly. We need to think a little bit about failure modes on this. Recently, there was a power outage in San Francisco a while ago, and it stranded a large fleet of self-driving automobiles. And the typical solution when a single car is stranded is, the system then goes and asks for a human supervisor to take a look at the data and confirm a particular decision that's being made. or being proposed. In edge cases where you have a large scale power outage and you have an entire fleet of vehicles, you might have just a handful of humans because the robots are making the decision most of the time on their own. And they don't need a huge amount of human assistance. But suddenly, when an entire fleet tries to call a help center, essentially, and you can wind up with a bad customer experience where those 12 humans can only park so many cars per minute, and it can take hours to recover from that sort of thing. So these are the sort of things we need to think about. How are we managing edge systems, and then how do we supervise and handle these odd edge cases? These edge systems are distributed. They require distributed management. So you've got data and things happening, and decisions being made in individual systems, but then from the central control point in the cloud, you need to be able to see what's going on. So you've got a little bit of a mix back and forth. But again, a lot of this goes to the complex workflows that we were talking about before with composite AI and having multiple agents and systems. We have a similar thing here where we have a network of AI, and these devices interacting generate some interesting management challenges to be able to reliably deliver things on a continual basis.
Tiffany, can I give a quick feedback?
Yeah.
Sure.
Okay. And I realized, Tom, yes, we are in that transition from control in the cloud to moving control to the edge. But that trend is inevitable. So the systems, and maybe we're not there yet, that we are building or designing need to include autonomous behavior, because network is fragile, power is
Yes.
also fragile. So network will go out, power will go out. So the system needs to be able to continue within boundaries when there is no connection with the mothership.
Yeah, and that's one of the strengths of edge AI. Good point.
Thanks, Johannes, and thanks, Tom. Well, in addition to unlocking speed and real-time decision-making, Edge AI also adds complexity, as Tom mentioned, with multiple models, data streams, and constraints all working at the same time. So this is where composite AI can really accelerate success. Scott, how can composite AI accelerate success with Edge AI and IoT?
Well, you're right. I mean, a lot of the systems that we're talking about are fairly complex. Composite AI is literally a composite of multiple components. So we're putting multiple things together. Now, you're going to need a good architect to design your composite AI system to determine how those tasks are distributed between its components and how those components interoperate with each other. But once you have that overall architecture, you now possibly have some loosely connected teams that can implement and iterate on the various pieces of that design in parallel. So this reduces both your development costs and your operational costs. And it also reduces the blast radius for when you have hallucinations or when you have to make design changes. The changes don't spread as quickly. Traditional AI components consume far fewer computing resources than LLMs, and that will also save you money there. You can also put, as Tom was talking about, instead of one large LLM, you can do multiple small LLMs, and those small LLMs can run on small edge devices. These devices are really, component AI is really a benefit for running some of these physical AI applications at the edge.
Thanks, Scott. And from edge devices to I have LLMs evolved over the past year, and what do you anticipate for 2026?
Well, so over the past year, and we've all experienced it, large language models have shifted in a very important way. In models like ChatGPT moved from being primarily reactive, answering prompts, to becoming more agentic. So they can now plan multi-step tasks, call tools, manage context over time, and operate with a degree of autonomy that simply wasn't there a year ago. And what's so important here is not just capability, but behavior. So these systems are beginning to reason across steps, decide when to ask for information, and determine when an action is complete. That is a significant departure from the prompt response pattern most organizations became comfortable with during the first wave of adoption. That evolution changes how LLMs are being used right now. They're no longer just interface of information. They're starting to function as coordinators, connecting data, systems, and actions across workflows. We saw this reflected in features like persistent memory, structured outputs, and tool use, which make models far more dependable in operational settings. Instead of helping one person think faster, they are beginning to shape how work itself flows. And as a result, organizations are quietly shifting expectations. The question is no longer, can this model help my team? It's becoming, which task can this system own and which must be supervised? That distinction matters because once a model participates directly in execution, errors are no longer academic, they become operational and need to be managed. So looking ahead to 2026, that agentic directions will continue, but a real shift will be cultural and procedural. Organizations will increasingly expect LLMs to do work, not just assist with thinking. And that raises new questions about reliability, oversight, and failure modes, especially as these systems are embedded deeper into core business processes. In other words, the models are getting more capable, but also more consequential. The technical progress is truly impressive. The discipline around how we deploy, constrain, and supervise these systems will matter even more in the year ahead. And the winners will not be those who adopt fastest, but those who adopt with the clearest understanding of responsibility.
Thanks, Johannes. Dr. Scott, was there something that you wanted to comment about Johannes's response?
Absolutely. Johannes, you make a great point. A lot of businesses today or the last few decades have been the mantra has been do one thing well and just do that one thing. Don't do anything else because you need to focus. But I think with AI, what we're getting into now is a lot more management kind of tasks, coordination kind of tasks, where we're bringing multiple of these do one thing well things together. And it's inherently a composite system of multiple tasks.
Yeah, it is. And it's changing everything. I don't have a clear picture. I think in a year from now, we have a better insight. But the whole field is shifting. The whole field of management is shifting. And you are spot on.
Thanks, Scott, and thanks, Johannes. Well, though LLMs and AI systems are powerful, the benefits aren't automatic. Organizations and teams have to adapt to harness them effectively. So, Tom, can you tell us how AI is impacting organizations and what should professionals be aware of in order to succeed in 2026?
Thanks. We've got. It's a good question. We're going to see a big shift in organizational theory and management theory. Up until now, organizations by definitions were organizations of humans. And if we fast forward a bit and we have humans that are forming departments, but a significant portion of their departments are AI agents, this changes the game a bit. We've seen this with some of the early experiments around unmanned drones that are flying with aircraft. And you used to have pilots and you had wingmen and you had this squad commander who was in charge of the overall strategy. But what happens if there's only one human pilot and all the rest of the fleet that or the squadron that's up happens to be robots? There's some major advantages because they can do some things that would be hazardous or impossible for a human, but that puts all the management onto the one human that's on site. So we could translate this a bit to organizational theory that everyone then is a manager. You might be managing multiple AI entities. And how you manage is going to be a bit different. How you manage an AI or a robot is quite different than how you manage a human. We need to think about how this changes organizational culture. Many of the AI agents may be interacting not with humans, but they may be interacting with other AI agents. We had a case, I was talking to somebody about e-commerce, and if we have agents that are purchasing things, and they may be interacting with and placing orders and making financial commitments essentially with AI agents on the supplier side. So we can think about our supplier networks, traditionally what would be an ERP system. How does that change when much of it becomes automated? There's a number of things that start to come to mind with that. We also need to be aware of agents that are shared. So in a traditional organization, we have dotted line employees that report to two managers, and that may be fine. But we need to think about, what if you're sharing an AI agent? What's the potential that that AI agent, similar to a human that's shared, leaks information from one department to another? It may not be an issue if it's you know two different HR managers, but one of them is HR and one of them is a different function. What's the likelihood that my information may get almost like a rumor mill of the agents then working for the other management, the other organization, and saying, hey, it's retaining some memory in between these jobs. And does that present an opportunity from a cybersecurity perspective for information to leak or behaviors to bleed over between things? So we need to think a bit about these. The summary is that organizations that are comprised of humans plus AI we need to think about management, and people that were not a manager before may suddenly find themselves managers of AI, and that might require a different skill set than they happen to have today. So from a management perspective, it's something to pay attention to.
Tom, can I respond?
Yeah, please.
So coming back to your example of the drones, in a military aircraft, some of them you have what's called a weapon systems officer,
Yes.
or a different term that they give it different air forces. A similar role in aircraft is going to be for the drone systems officer. So that's an obvious one until the drones are getting so smart that they can take over that role. Now, and you bring up a good point. There in businesses, there will be a proliferation of AI managers for the data interaction, for the systems, etc. So a lot of people. That's the reason why I'm not so worried about AI taking away jobs. I think it's creating maybe even more jobs than it's taking away. And people that are working in an organization will need to upskill and will, well, if they like it or not, will turn into manager of an AI function.
Yeah, definitely.
Thanks, Tom, and thanks, Johannes. I think upskilling is a great way to go, because that way the person that was managing the human tasks can still keep an eye on things if the AI doesn't work out. So even with the right organizational strategies, success depends on how well companies manage and leverage their data. So, Scott, what challenges are organizations and professionals facing in 2026 when it comes to effectively using their data?
Well, AI and ML are awesome. We believe that. But the organizational issues also need to be examined closely. And there's a number of disciplines that I think are absolutely critical for all of these AIs to work out, but I don't think some of them get the attention that they deserve. Data engineering used to be one of those hidden disciplines, but I think companies now really understand its importance. A lot of companies think that their data is in really great shape, but I think the vast majority of them are wrong in that. They need to do a lot more work to ensure that they've adequately invested in their data management and their data management processes. The second one is really bias and fairness. It's kind of another sleeper area. People are already starting to talk about it a lot. You're seeing press about it, but I don't see that businesses are really executing on it like I think that they should. So that's another area that the organization needs to invest in to make a fertile field for AI to flourish. And then the last one is that I wanted to highlight is organizational change management. I think very few companies are even really considering change management for their AI projects. You really need proper change management to make sure and improve the chances that your users will actually adopt the AI. Because if your users don't adopt your new super cool AI application, your project is a complete and utter failure. No one's going to use it. So I would encourage organizations to not ignore change management.
Thanks, Scott. That's a great point. And another layer of complexity surrounding data is the ability to distinguish reliable information from AI generated content that may appear real but isn't. Johannes, we're seeing some very convincing deep fakes. Do you have any guidance on how we can discern misinformation?
Well, Tiffany, deepfakes are a problem, but they are only part of the problem. And we saw that definitely in the past year. So what has changed most, definitely over the past year, is that all forms of impersonation have become more convincing. Phishing emails read naturally, phishing calls sound calm and informed, smishing messages reference real context, and video, which is what many people still treat as the strongest form of proof, is no longer inherently trustworthy. And that's the uncomfortable reality. Visual or tonal realism is no longer a reliable signal of truth. Video can look right, sound right, reference accurate details, and still be fabricated or manipulated. So the question is no longer, does it look real? It is, can this be independently verified? So when it becomes specific to video and deepfakes, the first step is to stop treating realism as a validation. Instead, look for contextual consistency. Where did the video come from? Is it coming from a primary source, or has it been reposted and reframed? Is there corroboration from trusted independent outlets, or is the clip circulating in isolation? Second, pay attention to behavioral plausibility, not just technical artifacts. Many deepfakes today are good enough to pass visual inspection, but they often fail on intent. Is a message aligned with how this person normally communicates? Does the request create urgency, bypass normal process, or ask for something that would usually require confirmation? Those are stronger signals than pixel level analysis. And third, and this applies far beyond video, separate communication from authorization. A video request to transfer funds, share credentials, or approve access should never be sufficient on its own. Verification should happen through a second, independent channel, a known phone number, an internal system, or a direct confirmation path that the attacker cannot easily spoof. And this is where a light version of zero trust becomes practical, not as a heavy security doctrine, but as a daily habit. Trust the relationship, verify the request. As impersonation becomes easier, verification becomes less about technology and more about discipline. Deepfakes will continue to improve. Organizations and individuals who fare best will not be the ones who can spot every fake, but the ones who design workflows where a convincing fake is not enough to cause harm.
We've traditionally been at the executive level been dealing with what's called whaling. So somebody who wants to compromise an organization will target an executive and spend a month researching everything about the executive and know their schedule, who their direct reports are, and all of the information that they can gather, and launch a very sophisticated attack that leverages internal knowledge that makes it sound even more real on top of the deepfake. And the saving grace was that we only needed to train the executives on how to spot these sophisticated attacks. With generative AI, these sorts of attacks are becoming significantly easier. So I expect that we will see a very high level of sophistication in future attacks where people are trying to do business email compromise and send information with a deep fake, but also leveraging a month's worth of research that they were able to generate in just a matter of minutes and build a customized attack for somebody who's not at the executive level.
Well, and to add to that point, Tom, so I think organizations also need to be careful with what information they put out there. For example, does a keynote from the CTO or the president need to be in the public domain? If it is, then it's going to be misused for a deepfake, for example. So I think that this requires an adjustment on the company side, how to deal with what information they make public.
Thanks, Johannes, and thanks, Tom. You both had great points there. It becomes very questionable on what data to share, and even just sharing photos. What's in the background? Is it your address? Is it a bank card? You have to be very cautious these days. And identifying misinformation is just one part of the trust equation, because organizations also have to put trust into the AI systems that they depend and rely on. How these systems are designed, validated, and monitored can make all the difference, as we were just talking about. But Tom, can you tell us your thoughts on the increasing importance of trust and how it's being written into the design, as well as how to gauge confidence in AI answers?
Absolutely. So one of the biggest barriers, we've had a couple of barriers to AI adoption. And so as we're rolling things out, the fundamental underpinning of AI adoption is based on trust. Similar to doing business with a new vendor or another human stranger, you need to trust that you can work with this person, the information they are who they say they are, that and actions that they take are within what you expect. And so we have the same thing with AI. Every time there's an AI system spinning up, there's a level of human trust. In studies where we've talked to people about why they weren't adopting AI, especially on the consumer front, the number one factor is always trust. I don't trust this. If we want to, as an industry, leverage all of the AI innovation available to us to elevate things to the next level, we need to have trust of our everyone that we do that is exposed to the AI, either directly or indirectly. To do part of this, we need to really take a risk-based approach. And every time we can minimize the risk of something happening, then we're increasing trust. It's a bit of a challenge. We can't necessarily use our existing techniques of spotting unusual behavior when something is coming off the rails, because AI is non-deterministic, and it may make different choices given the same situation or the same inputs. So we see this with ChatGPT. I can ask it the same question 3 times. I'll get slightly different answers. This makes it much harder to tell if something is on track or not, just using straight mathematical analysis. So at the end, we need to spend some time looking at risk when we're deploying these systems, ask ourselves what's the worst that can happen, and think about that and spend some time on that. We will never be punished for analyzing risk. It's viewed as being responsible, and that's how we get to trustworthy AI, is managing this risk on an ongoing basis, not only in the design of the system, but also in how we operate the system and how we manage the system. And so we need to have a culture of risk and risk reduction as we roll these things out. That goes to identity of AI agents, the bill of materials from our suppliers, other software libraries we're using, just making sure that everything has been de-risked as much as we're humanly able to.
Thanks, Tom. And trust in AI systems is essential, but those systems are only as good as the data that they use. And organizations need to know that their data is reliable to make confident decisions. So, Scott, how do you trust your data?
Well, both Johannes and Tom have talked about trust kind of from an organizational level. I am kind of thinking about it in particular from a technical level. And I think that is one of the reasons why composite AI is pretty good. If you use, it includes both non-LLM traditional AI algorithms. And the reason that we do that is because you can't always trust LLMs to be completely honest. But you can strategically use some traditional AI algorithms to check and verify many, but not all, system outputs. Traditional AIs are explainable, they're interpretable, and they're transparent. I don't have time to describe all of those specific terms, but they each refer to some specific aspect of trustworthiness that is important. Many AI algorithms, many traditional AI algorithms guarantee some optimal technical results. But again, don't forget about change management. It's instrumental in building some of the building trust with your user base and other organizational results.
Thanks, Scott. And even with trusted, reliable data, organizations face another challenge, which is security. As AI and new technologies evolve, so do the ways that attackers exploit systems. And we even covered a story about an AI powered attack in TechScope News. Johannes, with new capabilities and tech being released constantly, how are the attack surfaces evolving for cyber threats?
Well, Tiffany, attack surfaces are definitely not shrinking. They are alive, well, multiplying. So every new capability, AI agents, APIs, connected devices, automation tool, adds another surface, another dependency, and another assumption about trust. What used to be a defined perimeter has become a constantly shifting web of systems talking to each other, often autonomously. In many organizations, no single team has a complete picture of all those interactions. The challenge is no longer just scale, it is motion. Attack surfaces now change as systems update themselves, models evolve, and integrations are added on the fly. An environment that was secure last quarter may be significantly different today without a single deliberate architecture decision. Security is increasingly dealing with drift, not design. AI accelerates this trend. Agents act on behalf of users. Models connect directly to tools and data sources. Decisions trigger real world actions. Each handoff between model and tool and system and human creates an opportunity for misuse if identity, authorization, and intent are not clearly enforced. In other words, the risk is less about one big breach and more about many small, hard to see failures compounding over time. Another shift worth noting is that attackers are also automating, and we've shown that in TechScope news. So their current mode is that they probe continuously, adapt quickly, and exploit temporary misconfigurations that might only exist for hours or days. That means defenses designed around static snapshots, asset lists, annual reviews, one-time assessments are increasingly out of steps with how attacks actually happen. The takeaway is not that innovation should slow down, it's that security assumptions must evolve just as quickly. Organizations need continuous visibility into what is connected, what is authority, and what can act autonomously. Clear ownership matters as much as tooling. Someone has to be accountable for how systems behave, not just how they are deployed. And in 2026, the organizations that struggle will be the ones still treating attack surfaces as fixed. The ones that adapt will recognize them for what they are, living systems that require ongoing attention, disciplined boundaries, and constant revalidation, not occasional audits.
Thanks, Johannes. And understanding the changing attack surfaces is just part of the story. As technology advances, so does the array of cyber threats. Tom, what other cyber threats are on your radar for 2026 and how should we prepare?
Thanks, Tiffany. I've got a handful of things. We already touched on AI-powered attacks and some of the other threats in there, but there's a few other things that are concerning. One of which is and this happens with every emerging technology. We spend our time getting it running, and that's the primary focus. And we want to launch this thing and see it out in the world and what it can do. But if we're not taking into account security, there's a bit of a misnomer going around where people think that rather than um, taking security considerations as part of the requirements of a system, what they're doing is they're building an entire system. And in the last 30 days before it launches, they say, well, can we bolt on some guardrails? And in general, when you have a system, if you're building a bicycle and then you decide somebody at the last minute says, oh, this needs to be armored, none of the components of the system are going to be able to handle the weight and wind up cobbling something together that technically has guardrails, but actually from a systems perspective doesn't perform the function that it's supposed to well. And inevitably, this leads to redesigning the whole system at some point. So you can. One of the things I'd like as a takeaway for people to not think of guardrails as something we bolt on in the last 30 days before something launches, but actually sit down at the very beginning when they're trying to figure out what they're building, asking what are the things that can go wrong, and let's reserve some spaces for some controls. We can put controls in certain spots just in case. We don't need to put all of them in on day one, but if we reserve a spot for those, then it won't be a huge amount of technical debt to implement those should they be required. The other thing that I'm seeing is protecting. Historically, we've spent our time protecting data, but we also need to think about protecting controls. As we're seeing physical devices out there that are interacting with the real world, they may not have, a stoplight, for instance, doesn't contain a lot of information that's valuable. It's not likely to result in a privacy leak. But if somebody takes control of that and they have nefarious purposes, that can cause a great deal of damage. So we need to think about not just data that we've always thought about and privacy we've always thought about, but thinking about physical controls. And then the last thing, I'm spending a great deal of time around digital forensics. If something goes wrong, do we have law and do we have systems in place that we can tell what happened? We need a black box, essentially, that if something suddenly goes haywire, we can gather enough evidence that we might be able to start to understand what happened. And then we're dealing with things like rogue agents. If somebody modifies an agent, how do I know the agent I've deployed is the one I intended? And for the governance point that was made earlier, we need to make sure that we don't have a compromised element of our system that will then be the ultimate insider threat because it has permissions to access everything.
Thanks, Tom. So much great advice in your response. I love it. And security and privacy go hand in hand. And as threats evolve, so does the equation of which data to share and what to keep private. And this is a key factor in establishing trust with customers and stakeholders. So, Scott, how does an organization choose what data to share and what to keep private?
It's a great question, Tiffany. Personal privacy is coming under attack from many quarters right now, as we've already talked about. But it's especially crucial in these highly regulated industries like healthcare and finance and legal. There are some traditional AI approaches that will help address some of those. I'd like to highlight just federated learning, which is one such traditional AI approach. It's been around for a number of years. But so consider a bunch of hospitals, maybe 5 or 10 of them, and they want to train an AI model over their combined large patient data sets. Now, hospitals really hate letting their raw patient data ever leave their systems. And with federated learning, they don't have to. So the way this works is a central site first prepares a first pass AI model, and it shares that model and all of its structure and its parameters with all the hospitals. Then each hospital trains and improves that model locally using their patient data on their own systems so that no raw patient data ever leaves their walls. Then all of the hospitals combine their updated model weights, and I'm talking about model weights, not raw patient data. They're sharing their weights, and that produces an improved AI model. Then, of course, they can repeat this process multiple times to continue to iterate and improve the model. The nice thing about this is the final model has been trained on all of their data, but no patient data was ever shared. That's just one example of a traditional AI approach that allows us to improve privacy, keep things private. But there are others. Don't really have time to cover all of them, but there's homomorphic encryption and zero knowledge proofs. Johannes referenced the zero knowledge proofs a little bit. There's a lot of work underway on that. These aren't necessarily cheap approaches. They can be kind of expensive, but they also can give you a lot of privacy.
Thanks, Scott. And as we look at data visibility, another trend comes to mind, which is AEO. Making information that you do intend to share discoverable and accessible is the next frontier. So, Johannes, can you tell us why organizations should be aware of AEO and some tips for succeeding with it?
Well, first of all, Tiffany, AEO, and you mentioned answer engine optimization or AI engine optimization, it has the same foundation as SEO. And we've been working with SEO for decades now. But AEO raises the bar significantly. So it's no longer enough for information to exist or even to rank. It has to be structured explicitly and trustworthy enough for machines to extract, interpret, and present as an answer. And that's where many organizations underestimate the challenge. AEO is labor intensive. It demands clear definition, disciplined language, consistent structure, and ongoing maintenance. And there are no shortcuts to AEO. And even when it's done well, AEO and SEO on their own are no longer sufficient. Because what has changed is where the discovery happens. Increasingly, information is surfaced through large language models, agents, and conversational systems that do not behave like the traditional search engines that we've been used to over the past 2.5 decades. So these new systems pull together information from many sources, infer authority implicitly, and deliver answers without sending users to a website at all. In that environment, ranking matter less than representation. This creates a risk that many organizations have not yet confronted. Systems may be speaking about you, about your company, for you or your company, or instead of you, without any visibility into what they're saying or why. If an LLM summarizes your organization inaccurately, omits key context, or defaults to a competitor's framing, there may be no obvious signal that this has happened. And that's why awareness has to come before optimization. Before you can improve how you show up, you need to understand how you are currently being described. So over the next few weeks, we will be rolling out a set of tools designed specifically for that reason. An AI visibility snapshot to provide a fast model-level view of presence, an AI visibility and stability engine to examine consistency across runs and prompts, and a deeper LLM presence audit focused on diagnosis rather than ranking or promotion. And the reason this matters is simple. In 2026, visibility will not be measured only by traffic or search position. It will be measured by influence inside intelligent systems. Decisions, both human and automated, will increasingly be shaped by answers generated upstream of any website visit. So the real question organizations should be asking is no longer just, can we be found? It is, when machines speak on behalf, are they saying the right things? And how would we even know if they're not?
Thanks, Johannes. Definitely something to keep on your radar. And so far, we've covered existing technologies, but what about preparing for technologies that are still on the horizon? Tom, although quantum may seem a ways off before we see Q Day, what tips do you have for organizations to begin preparing now?
Yeah, that's a great question. So for those of you not familiar what Q Day is, we have a new technology that is surpassing traditional computers that is called quantum computing. And that leverages quantum physics, essentially, to store and process information in completely new ways. Why is that relevant to us? The answer is that at some point, because of the way it processes information, a quantum computer will be able to break all of our, or a significant portion of our encryption mathematics. So today, most of our things, ranging from the badges we use to open a door, to our hard drive encryption, to our VPN that we log in remotely to work, those are all protected by what I like to call one-way math, that you can solve an equation one direction very easily. It's trivial. And if you want to do it the other way, it will take you 40 years or 100 years or some huge number that basically makes it not feasible for you to be able to decode the messages back and forth. With quantum, the math that we're using is subject to being broken by a large quantum computer. They're slowly getting larger each year. But at some point in the unknown future, we'll have like a Y2K type problem that we will need to upgrade all the math used in all of our cryptography. And that's going to present a little bit of a problem. What we need to do, we've been using the same mathematics, but just longer and longer numbers, essentially, for quite some time. And so a lot of the systems that we built today aren't modular. You can't swap out to go to new math. Uh, we are going to have a plan, and there's two takeaways from this. The first is that we need to achieve what's called crypto agility, that we can put new math in as the old math gets broken and upgrade. But this will take two things. One is we need an inventory of all the places we're using cryptography within our organization, and you will find surprising places. Almost every wireless device, you can go down the list. And again, I mentioned some of the places you might find it. And then the second thing, once you have that list of places that you are using cryptography, identify what's the level of risk or the impact if somebody were to record messages and be able to decode them. And then we need to talk to our vendors and ask them what their plan is to go to post-quantum cryptography mathematics. So we're looking for PQC is the term, and just ask them, hey, what's your plan to be able to upgrade to this? Because in client server, we probably have to upgrade to be able to do both old and new math and have a transition plan. And so our vendors should be starting to think about these things so that, it could be 10 years from now, it could be less, could be more. But when that day comes, it would be great to have a plan in place. So we like to plan ahead.
Thanks, Tom. You totally answered the question that I was envisioning, because I was going to ask you about how long do we have. So if you have questions, please feel free to drop them in the chat. We're going to do Q&A here in just a few moments. And from quantum to AI, trust to cyber readiness, we've certainly covered quite a lot of ground today. And before we wrap up, we wanted to take a moment to highlight Knowledge Reactor, who is supporting the event. So Scott, can you tell us more about your services and any final thoughts that you have for our audience?
Absolutely, Tiffany. I love AI. I've studied it for decades. I've taught it at the graduate university level. I develop it, I write about it, I implement it. And I do have some materials about Knowledge Reactor in the Knowledge Reactor sponsor area of the TechScope Connect platform that you can download if that's of interest to you. And I also help clients with AI and ML education, with consulting, and with implementation. I also do a lot of speaking to both public and private events. So if you're interested in applying AI or ML to some of your business problems, let's talk about it. I can help you visualize some AI possibilities that you probably haven't even considered.
Thank you, Scott, for your support and for sharing your 2026 insights with our community. And if you'd like to connect with Scott or invite him to speak at one of your events, you can connect with him on TechScope Connect. He is a featured thought leader. Or you can also connect with them on LinkedIn, of course. And there is the sponsored area that is featuring the Knowledge Reactor information. So be sure to download those materials. And I also want to say a thank you to Johannes and Tom for being part of this discussion, as well as our team at IoT Marketing, Rose and Jason and everyone. You've been so helpful. And thank you so much to our audience for joining us. So if you're watching on LinkedIn or YouTube, we've got a lot more to come today. So be sure to sign up now at techscopeconnect.com/events to catch all of the other sessions, because we have a full day of keynotes, fireside chats, and more to help you stay tech ready, informed, and ahead of the curve for the year ahead. So thank you so much, everyone. All right, and we are back with Q&A. So, hello, first of all, to our audience who's been chiming in on where they're watching from. Rob from Houston, Rose in Rapid City, Dienpro in Ukraine, Gregory from Atlanta, Chris from Redwood City, California, Ken from Raleigh, Brian from Cincinnati, Omar from Latisse, Pennsylvania, Halal from Istanbul, Turkey, Ravi from Bangalore, India, and Tina from Wellington, New Zealand. So hello to all of you. And so for our first question, and anyone can answer, from LinkedIn, MIT just released research showing 95% of generative AI pilots are failing. And it's not because the models aren't good enough, it's because organizations can't actually integrate them properly. IBM found that 45% of companies are stuck on data accuracy issues, and 42% don't have the right expertise. The gap between what AI can do and what companies actually support gets wider. Do you feel this is accurate? Why or why not? And what can be done to improve these odds?
I think one of the major issues is change management, like we talked about. If you're just building your AI model in a vacuum, um, how do you know it's going to fit? How do you know it's going to be useful to anybody? How do you know they'll even accept it? I think change management is one of the issues that has to be addressed, and that's where you find out that early that you have this group of people needs it to do this, and if it doesn't do that, they're not going to use it. Okay, well then you fix that, but you can't just throw stuff over the wall and hope it's going to work.
And that echoes some of the things that I've seen out there, that we have an early technology. People are very anxious to get it out there because they see the potential. But it's not just the technology, it's the organization, the process, all of the other pieces need to be in place. You can only push technology so hard on people. You can tell that you've got the right mix when people are your end users are asking for something and they're telling their friends. But we don't have everything in place yet. We're still learning as an industry what's necessary, and a lot of people are only belatedly realizing they have extra requirements in the rollout that weren't part of an AI spec. They're part of an organization spec or a process spec or expectations that have been set with folks that weren't included in their original designs.
Well, my take is definitely that in the same MIT report, they also found that at the more personal level, at the individual level, AI is thriving. So people are adopting AI, using it for their own purpose, and that shadow AI deployment is alive and well and thriving. So there are definitely two sides to this coin. Shadow AI, just like shadow IT, has its dangers. So you're talking about governance, how you manage it. And but these big AI projects, as we seen over and over again, they do run into these roadblocks of managing change. How do you deploy it across your entire organization?
Thank you, everyone. And the next question kind of goes hand in hand with the last question. So it's many organizations moved from AI pilots to real deployment this past year. What's one operational shift leaders must make in the next 12 months to turn AI from a cost center into a measurable growth driver?
Well, I'm thinking. So, well, I would say people are. I mean, there is a very strong adoption of AI already. So, listen to the people, see what they need, what they want, and how they want to deploy AI in their personal work area. Now, the one thing that we need to keep in mind and is AI models or AI agents will need maintenance. So that's the part that if you deploy AI, definitely need to look at how do you maintain it, who's going to maintain it, and at the same time also look at the governance, who owns the AI agents that are everywhere in your organization.
And I would say as we move into the execution phase and we've stopped the experimental phase, when you get into execution, there's a handful of things. This is a bit of an experiment in many ways to find where the most impact is. And when you design information systems and you hand them to people, there's typically a little bit of a gap of a few percentage points of what was delivered versus what the expectations were on the end user side. And the users don't fully understand exactly how the technology works, and the technology folks don't understand how the user works. So closing that gap is key to deriving adoption and essentially value creation at that point. Pay attention to the value, treat it like a beta test in the beginning. Like you're getting early customer feedback, and if you can figure out where the holes are early, that can save you a lot of technical debt. One of the worries with emerging tech is that you can build something and only belatedly realize certain extra requirements the user had that weren't communicated to the folks that created the system initially. And learning things later is costly. So if you want to get to value creation and positive ROI, it needs to start focusing on the full solution and where the value is, and then wrapping that up in discovery and an iterative process that you can improve upon.
I agree with everything you said, Tom. I think as a the technologist, it's easy to say, well, we're going to shoot for this level of accuracy or this level of error rate or something like that, and that's nice. But it would be better. You'll have much greater success if your KPIs that you're trying to hit are actually business KPIs. We want to get 10% more customers this next quarter, or whatever that is. If you start out with those kind of KPIs, it will tend to drive all of the other parts of the organization to fix that, right? I mean, it's like, well, we're going to need at least this accuracy, but we also need the salespeople to do this, that, and the other thing. So pick the right KPIs up front will help. There's no one easy answer to this, but that will help.
Thank you, everyone. Those are some great points. And I'd also like to add, I think that you should probably try to figure out and pinpoint exactly what's going wrong, what's failing, and then figure out how to fix it. That'd be my advice. But Scott, you were right on point with our next question that came through the audience. What KPI should leaders be watching right now?
It depends on your business, and it depends on your domain. Some people are trying to drive more sales, so sales related KPIs are important. But if you're in manufacturing, maybe it's an error rate, or how many parts are failing at the end of the line. Maybe that's the right KPI. I don't think there's a one size fits all here. You have to look at and two businesses in the same industry may still want very different KPIs because they have different problems with their own business.
You have problems. You have different, probably as many different KPIs as you do business strategies. So as you think about where your business is and what the goals are, most of you at this point have been through the 2026 budget and setting strategic goals and getting everything lined up. And if you were to compare with peers in your industry, as Scott said, that you'll find differences based on what your goals are. So as I think one of the things is to step back and not be intimidated by the technology piece so much as focus down on the business objectives and the strategy, and what do you need to drive that strategy forward. And the answer will involve some AI things. They'll have a piece of that, but you need to have a holistic approach.
Well, it also depends, the KPIs depends on what level in the organization are you talking about. Are you talking about corporate level? Are you talking about department level? Are you talking about team level? So there will be, and it depends on how far you've rolled out KPIs in your organization. So at each level, there are several KPIs that you should consider simply to manage the rollout, manage the deployment, and also manage the AI.
All
I
right.
think there's
Thank you so
actually
much.
another element to this too, that if your plan is to make $500,000 by this deployment and people don't like it, it's they're not going to say, well, we can't do it. It's like, I'm not giving up the $500,000. So that will help drive things through, even through the bumps in the road as you get started.
Thank you so much, Scott. And we have several more questions, so I'm going to try to zoom through these as quick as I can. What's the fastest win that most organizations are overlooking?
I tend to have a longer term view of building the business and the strategy on not what can we do next month. So I have a little trouble coming up with something. I find people more often chase a few short term things and then have to undo a lot of work because they missed the longer term goal. Uh, Anybody else have any ideas on that one?
I think it depends. It depends on what your goals are, as we talked about already.
Mm.
Well, if you're looking for a quick win, then I would look at the shadow layer. The shadow layer around RPA, shadow layer around maybe low-code deployment, and see how an AI agent can help you manage those layers.
My response would be test, measure, and get feedback from your organization and mentors or other people that you respect in the industry. What's one example of physical AI being used now that you think will be mainstream in 2026? Robots.
I think robots is the one thing that we saw a ton of at Consumer Electronics Show. And if any of you watched the news this morning, there was an announcement that Tesla is going to be modifying one of their primary early factories in California for robot production. So I think we're just on the verge of seeing that. Whether that becomes absolute mainstream early on, I think we're still kind of in the adoption process. It may take longer than 12 months to get that ramped up. Judging of, we'll see the early adopters. There'll be a lot of attention on this, but this transition getting to the point where they're controlled by an AI that can, an AI agent that can make decisions and take actions independently. We've seen this with self-driving taxis. Bringing that to general robotics is absolutely going to drive things that have never been possible before.
Well, we'll see definitely more pilots this year. And Hyundai and Boston Dynamics have mentioned the plan that they want to introduce up to 30,000 robots in a Hyundai auto factory, but that's 2027. So I think 26 still a lot of pilots. 27 is when you'll see the first deployments happening.
Yeah.
All right. And the next question, how do you balance giving a machine autonomy while still making sure it doesn't make mistakes in real world situations?
One of the things we need to think about is what's on a case by case basis, depending on what jobs are to be done and what capabilities a robot has. We need to look at that and scale the answer appropriately in terms of autonomy versus control. If it's something that can harm a human, we definitely put more controls in. If it's something that can empty our bank accounts or erase all of our data, again, that's a high impact potential. And so, like in the security world, we look at what's the seriousness of a security vulnerability. What's the impact if that gets broken? What can happen? What damage can be done? And then scaling it appropriately. If it's something that has limited capability, then we don't need to spend as much time securing it. There used to be an old saying is like all bicycles weigh 50 pounds. If you have a 50-pound bicycle, you don't need a lock. No one's going to haul that away. It's too much of a hassle. If you have a 5-pound bicycle, you need a 45-pound lock in order to keep somebody from stealing it because it's so valuable. So you need to think about scaling your risk and your security controls to match the risk so that you're not overspending in the wrong spot or underspending in the critical spot.
I would also add that autonomy isn't a yes or no question. There's a spectrum of things. You might fully authorize an agent to do something. You may say, well, it can only do it if I pre-approve it, or I may have authority to reject it after it's even going to do it. But if I don't act, it'll do it. So it's a spectrum of things, and you have to look at what you're doing to see what makes sense for you, just like Tom was talking about.
And yeah, it's all about boundaries. And Scott is right. Autonomy is not going to happen overnight. So you're going to slowly loosen the training wheels and see how the system responds. So you need to look at what Tom said, risk, doing risk analysis, also doing impact analysis, meaning negative impact analysis if something goes wrong. At the same time, because we do have teams out there that open doors from autonomous vehicles because the customers cannot get out. So it's also where you need to help in any autonomous tool. So it really depends, and it's really about setting boundaries and allowing the machine only to go so far before it does some serious harm.
Thank you,
And to
Johanna.
put things into perspective, like even human interns, when we hire them, will make mistakes. The catch is we've got enough supervision that we can say, "Oh, don't push the red button on the side," and so we need to think about that as well. If it's a low impact thing, and the color on a graph that's being produced is half a shade off of the shade of blue you asked for, is that worth that level of control? So, if we have a supervisor reviewing things that are risky, then if that's in the right spot, that really helps a lot.
Thank you. And the next question says that this person saw an article about a recent research paper that said AI agents are mathematically incapable of doing functional work. Well, where do you fall on this new research?
I'd be curious what the
Define
functional work.
functional. What is functional work?
Can you please elaborate? The person that submitted this question. All right, we'll go ahead and skip to the next one. With LLMs getting more autonomous, how do you decide which tasks an AI can handle and which still need a human?
It's what Tom was
Again,
saying. Look at the risk. What's the risk of a failure? Because if it makes one error that's not too costly, it's cheaper to pay to fix the error after it happens. But if it's going to make a lot of errors or a serious, highly consequential error, that's what you have to look at. And you just have to do a lot of testing. And like I said, I think a lot of the composite AI stuff, you put checkers in there that are deterministic, that check and see whether the answer is believable or correct. So LLMs can do a lot, but they're not really good at deterministic. They don't do deterministic checking.
There's that sliding scale between creativity and a deterministic answer, which is one reason why there's some struggle with mathematics. But we build a compound system, as Scott said, that pulls that out and treats that with something different.
and also treat them as an intern, if you like, and see how they respond and react in this certain situation, because they may be more limited than you want in approaching one task, or they may be more aggressive than you want in approaching another task. So observe, it's a new entity showing its own behavior, and we need to learn how they respond and control, and of course, yes, do the risk assessment.
Thank you. And I was just sent the link for where that research came from. So if you guys want to take a look at that, I'm not sure if we'll have time to answer that in this session, but we can post an answer to it in the chat. Next question is created due to Rob's comment in our LinkedIn event. He was asking about AGI, and so how close do you feel we are from AGI, and what needs to happen prior to that, as well as what do you see happening after that?
I think personally, I think AGI is overhyped. I don't think we're that close to it. Andrew Ng is also one of the guys I quoted earlier, doesn't believe that. I'm with him. They're amazing, but so are humans, but they have different capabilities. So I don't know what comes after it. I may be dead by then.
This is spoken like the economist that we used to be asked too many questions about what's the long run impact. But I also think AGI is some distance away. The difference in magnitude between an agent that's performing a specialized function and something that is near human and can walk around, um, that's an order of magnitude in complexity. Not saying we won't get there. I think we've gotten excited seeing what agents can do and what Gen AI was able to do, and I think people have thought, "Wow," and they sort of jumped ahead to the end of the book to find out, what the conclusion was. So I do think we'll eventually get there, but I don't think that's quite as soon. And I think we'll have our hands completely full um, rolling out agents and agentic robotics and all of these other things that are going to keep us very busy for the next 2 to 3 years easily. So I think we won't see it before then.
For our audience that's unfamiliar with this term, AGI, can one of you explain what AGI is and maybe compare it to our existing capabilities?
AGI stands for Artificial General Intelligence, and the thought is that intelligence is comparable in intelligence to humans. Some people think that that some AIs have passed human capability in some areas, but AGI really suggests it's comparable in essentially all areas. The other thing I would note is that Jan LeCun, who was the chief AI officer at Meta, just recently resigned. He was also one of the Turing Award winners. He recently resigned because he thinks LLMs are a dead end to getting to AGI, and he's going off and working on a thing called world models. So you might want to look that up. But I think we have time to figure some of this out.
Thank you. And with companies releasing new edge AI hardware and accelerators this year, how should organizations think about edge AI versus cloud AI for real-time decision making?
Well, I mean, we spoke a little bit about that earlier. Some of this comes down to kind of traditional architecture of systems. Do you want decisions to be made um, at the endpoints? Uh, there are many things that could be done much more efficiently and quickly if you put enough compute power or you have enough compute power at the edge. So making that an easy thing. Or whether things will scale better. So you're balancing the cost of the endpoints and how much horsepower needs to be at the edge versus how things will scale, and how much data is moved between the edge and the cloud core. One of the examples I went through some time ago, probably 2+ years ago, I was at a presentation and somebody was talking about the difference between having a very inexpensive doorbell and all the video feed goes to the cloud for processing. But the question is, that's dumping everything on the cloud. So you wind up with a very large cloud bill. But if most of the processing can be handled in the doorbells themselves, you may have a more expensive doorbell, but your cloud uh, compute load is much lower, and you get a much, you also save on response time. If it can be a local decision, you get an instant answer, even if the internet or communications are down. So it's a question of sort of what problem and the nature of how that scales up as an algorithm of how much do you want to do on the edge quickly and reliably without communication versus and how much are you willing to spend on the endpoint versus how much are you spending on the core. So it's a hub and spoke at the end of the day, and do you spend more on one or the other depends on what that looks like from a business standpoint.
Thank you, Tom. And I think we're cutting it close on time, so that's going to be the end of Q&A. But thank you so much to our audience for joining us. We've got plenty of more sessions coming up next, so stay tuned. And if you happen to be watching on LinkedIn or on another one of our streaming sites, please join us at techscopeconnect.com/events, where you can watch all of the rest of the sessions happening today. We've got content for the next few hours. So please be sure to tune in, and thank you again to our panel for joining us. You did a great job with all of the questions that we had submitted today.
Great questions.
Thanks, Tiffany.
Thanks, you.
Tiffany. Thanks, guys.
Hello, everyone. My name is Adam Ibrahim. I am founder and director of AI Rise Global Solutions and also founder and president of the World AI Federation. I am based in London in the UK, and I've been in the AI industry for just under 2 years now. I'd love to give my perspective on what I've witnessed and what I've seen in the AI world in the last 1 year, and to give us a small overview and also some tips for corporate businesses and businesses in order to be able to implement projects and to kind of understand where everything is going into this new year of 2026, which I believe will be very, very kind of spectacular in human development and also within technology and AI. So without further ado, we'll go to my first slide. So I've done the slides based upon the most popular questions, which I've had to answer myself in order to be able to give you a great insight here. So the first question which I had was, what was the most misunderstood aspect of AI progress in 2025? So 2025, from what I've seen, speaking to many, many global businesses, was not the year that AI became smarter, as you know, that we may think. It was the year where many organizations were actually exposed. And this exposure created weaknesses that already existed, but came more to the forefront of the businesses. And to give some examples of, what kind of exposure has happened, it revealed weaknesses that was already existing. However, these weaknesses were not too visible due to the long time process it takes to make decisions, to analyze data, and to obviously push forward the operation of the company. So this has now, in terms of a time frame, really shrunk, and due to AI. And now due to this, there's an exposure. One of the major aspects which I've seen regarding this is exposure is poor data quality. Now, I've been championing a certain phrase over the last year or more than a year, and this is that AI automation plus chaos equals automated chaos. So what this means is AI doesn't actually create bad data. It politely stops ignoring bad data. Therefore, bad data comes more to the forefront. And then this has a big, huge impact in terms of the progression of the AI. So another weakness that's been exposed is slow decision making, as I've mentioned previously. So what used to take weeks